All right, let's jump right into the warm-up then. And I know y'all are going to get the right answer. So we will quiz tomorrow. Tomorrow we will have our quiz. You'll have a question very similar to this. So remember that before you go ahead and grab a calculator and start typing anything in, this is just a great rule of thumb across the board. You need to make sure that whatever it is you're typing into your calculator has already been written down on your paper or your iPad. Because what that means is you have already thought about the problem, okay? So don't just start typing it in. So if we want to convert this to decimal degrees, we have 147 full degrees. So that's still going to be part of our answer, right? We're interested in converting the parts of the degrees, which, like parts of hours, are in minutes and seconds. So we need to convert 29 minutes back to hours, or in this case, degrees, which is not quite half an hour, right? So it should be a little bit less than 0.4. And then 13 seconds, we need to convert that back to degrees, right? And you could either do it by way of minutes or you can go straight to hours. So here's what I would expect to see on the quiz. 147 degrees plus, you could do 29 divided by 60 degrees plus 13 divided by 3600 degrees. That would be about the least amount of work you'd have to show, okay? Now, why does that work? Well, here's why it works. You can also show this, which is what we did several days ago. 147 degrees plus 29 minutes, and then you're going to multiply by 1 degree over 60 minutes. And I use the multiplication symbol there. It's probably bad. Let me use the dot and put that over 1. Now, dimensional analysis or stoichiometry, whatever you want to call it, is really your best friend aside from parentheses in this class, because if your units work out to be what you want them to be, chances are you set it up right and you're going to get the right answer. So notice the minutes symbols in the top and the minute symbols in the bottom. So the minute symbols divide out. They divide out. And what are the units that are left? Degrees, right? Which is what we want. And then plus, we could do the same thing, but now we're going to start with 13 seconds. And so if you don't know that 3,600 seconds is 1 hour or 3,600 seconds is 1 degree, you could do it in baby steps, right? You can convert from seconds to minutes. And again, if you don't know what the conversion factor is, set up your units first, right? The double tick is in the top, so I need it in the bottom so it divides out. And I'm going to put the single tick in the top. So that's minutes and seconds. So what's the conversion factor? Is it 1 over 60 or 60 over 1? It's 1 over 60. Okay? And we know that that's going to work because the seconds divide out. But we're still left with what? Minutes, right? And we don't want minutes. So then I would have another conversion factor. I keep using the X. That's kind of, again, bad. Let's use the dot. Now I want minutes to divide out, and I want to go to degrees. So 1 degree is 60 minutes. And if you notice there, your minutes are dividing out, and you're left with degrees. Okay? So we have to divide by 60 twice, or 3,600 once. So there's the setup. We put plus signs in between because we're going to add it all together. We have full degrees, and then parts of degrees, and then parts of more degrees. And the reason we want to type it in one step is because we don't want to have rounding error. Those middle two, or the second and third calculation, they could be ugly decimals, and we don't want to have to write them down and store them. So we'll just type it in one fell swoop. So let's see what we get. I'll show you both ways to do it. First of all, the easiest way is the pink line there, and that's 140. Oops, clear, flush. There we go. So from the home screen, 147 plus. Now it's 29 divided by 60. If you want to use the horizontal division bar, you can. Alpha y equals, it's just more keystrokes, right? 29 divided by 60. And then plus 13. We don't need to worry about the ones, do we? Because multiplying by 1 is the same. So if you want, you could just say then that it's 13. And then we can divide by 60. And here's what you could do. And this is very important with math print. Since we're dividing by 60 twice, you could put in your horizontal division bar denominator 60 times 60, right? Because what's your calculator going to do? it's going to multiply the 60 times 60 first to get 3,600 and then do 1 divided by that. All right. What you don't want to do is what I'll show you in the next instance. Okay. So this should give you the right answer. Again, you don't have to worry about the ones because multiplying and dividing by 1 gives you the same. And you get this. And now we will report how many decimals? 3. So I'm running out of room here. Let me write it right here. 147.48 what? 6 or 487, either one. And then make sure when you're done, you put this little symbol there. That's the degree bubble, or the degrubble as I call it. I don't know if it's catching on worldwide, but I call it the degrubble. And there's your answer. Okay. Now, because you have your calculator, it's a real quick check to see if that does give us 147.2913. If this is our answer, just say second negative. That recalls the answer. And then go to your angles, right? Second angle. And then let's convert it, number 4, back to DMS. And if it's correct, we should get what we started with. Did we? Yeah, we sure did. Now, which answer is actually more accurate? 147.2913 or 147.486? 2913. Why? Yeah, there's more decimals. We didn't report the whole answer, right? We stopped after 3. So the DMS is a little more accurate. In this case, right? That's not always the case. All right. Let's talk about the other way to type it in. The other way to type it in is to not use the horizontal division bar. 147 plus, we get 29 divided by 60. Plus, and here's where some people can mess up, 13 divided by 60. Oh, and we need to multiply by 60. Is that going to work? No, because your calculator is going to do 60 in the bottom times 60 in the top. Those are going to divide out, leaving you a 1. You're not going to get the same answer. You get 160.483. Now, if that's an answer choice on the test, which, oh, that's a great one for me to put, you would dismiss it out of hand, right, before you even start the problem, because we're converting 147 full degrees, and all we're interested in doing is converting the fraction of a full degree back to decimals. And there's no way we're going to convert 147 and a part and make it become 160 and a part. There's no way, right? So you know you did it incorrectly. So if you are going to do it without the horizontal division bar, which is fine, you know, as long as you know what you're doing, you can either A, divide by 3,600, or just say divided by 60, divided by 60. Okay, if it's a factor in the denominator, you divide by it. There it is. Okay. And then one last thing. You're going to have to show the conversions on the test, but remember, there is actually another way. Instead of converting the answer you got back to this to see if it works, you can actually just type this into your calculator. So remember, the way we do that is, again, from the home screen, we go 147, and now we're typing in the symbols. So the degree bubble, remember, is under your second apps. That's your angle menu. Second apps is number 1 is the degree bubble. There it is. You don't need a plus sign. You just type in 29 and then go back to your angle. And then number 2 is the single tick mark, 29 minutes and then 13 seconds. Now remember, if you go to your angle menu, you're not going to see the seconds feature, right? It's not number 3. You don't put 2 in there twice. Where is it? Where's the second feature? Yes, it's on the home screen. It's on top of the plus sign. Yeah, it's the alphanumeric character on the plus sign because it doubles as a quotation mark. It doubles as a quotation mark. So you hit alpha plus, and there it is. Now, double check. Is that what I gave you to start with? 147.2913, and then you hit enter, and kaboom, 147.486. So there's a lot of different ways to do it. As I mentioned on the video or live, I forget what it was, I'm going to have you show me on the quiz how you're converting it, because I want you to know why things work. So you'll have to do that. But after the quiz, there's really no sense in me making you do that every time if your calculator will do the heavy lifting for you, right? So From there on out, you can use the calculator's ability to convert from one to the other. It's just two different ways to represent the same number, right? Parts of degrees, like parts of hours. All right. Everyone good on that? Any comments or questions? Quotes, quips, concerns, good clean jokes? Good clean jokes? No. Okay, sweet. I heard a really funny joke about amnesia over the weekend, but I forgot what it was. So, yeah. I just made that one up, right? Dad venture. All right. Okay, so how far did y'all get in the notes on the video? Like number 3? Y'all completed number 3. Okay, awesome. Thank you. So just to review, we're not looking at angles now that are just drawn arbitrarily on the Euclidean plane like we did on the very first day. I had you all draw an angle and it was acute and we rotated it around and we made it bigger or smaller. We're not going to do that anymore. That's what we do in geometry on a coordinate plane. Yes, Kenny. Oh, sorry. We're going to put it onto a coordinate plane. Once you put it on a coordinate plane and you standardize it, you can start doing coordinate geometry. Coordinate geometry. And that is basically the beginning of trigonometry itself. That's what René Descartes over there, you see the Cartesian plane on his poster. That allows you now to start assigning functions to things that involve rotation, okay? And there's a lot of things that rotate in the world. So if you remember, if we rotate starting on the positive x-axis, that's always going to be our initial ray. I'm just reviewing here. We're always going to assume that the initial ray is on the positive x-axis, always. We don't even have to draw it, okay? The terminal ray, though, is the one in blue. If we rotate this direction, which is what? Clockwise or counterclockwise? Counterclockwise. So I'll call that CCW. That's going to mean that we're rotating in the positive direction. And that's why the quadrants are labeled like that. Quadrant 1, and if we keep going, that's quadrant 2, then quadrant 3, and quadrant 4. And so in geometry, you mainly had triangles. You can't have an angle bigger than 180, but here we can. That just means we're rotating around into quadrant 3 or quadrant 4. And of course, we do not have to stop after one rotation either, do we? We can keep going and going and going and going like the wheels on the bus, right? Go round and round, and then the song doesn't stop. It continues round and then keeps round and right. See, we can keep going. If we choose then to rotate in this direction, which is the clockwise direction, that is going to be designated as the negative direction. So when I give you a measure of an angle in standard form, which is what we're going to be doing from here on out, it's a vector. It is not a scalar. A scalar is just a magnitude, but a vector has magnitude and direction, okay? So if I give you an angle of 35 degrees, that means we're rotating from the positive x-axis counterclockwise by a measure of 35. If I give you an angle of negative 35 degrees, which had no real context in geometry, that means we're starting on the positive x-axis and we're rotating clockwise by a magnitude, a scalar quantity of 35 degrees. Okay? All right, so y'all did example 3, and y'all remember how to do example F? Let's just go over example F together, okay, since I'm here live. It says draw the following angles in standard position. What does standard position mean? Initial ray on the positive x-axis, okay? Show the arc between the initial ray and the terminal ray. So this is just a Greek letter that we use to signify some angle measure. And we know it's an angle because there's a what up here? A degree symbol, right? A degrubble. Negative 57,631. Is that more than one rotation? Yeah, a little. So we talked about now how to find where this lands. We want to draw it. It's going to land somewhere in 1, 2, 3, or 4, or possibly on the axis itself. Because it's negative, you can either keep adding 360 degrees back, which is a full rotation, gets you back to the same place until you recognize the angle that falls between 0 and 360. But that could take a long time, right? And who's got that much time? We sure don't, right? Because There are other math problems waiting, and we got to get to them. So how do we do it? We divide by 360. It's essentially stoichiometry. We're converting from degrees to rotations, okay? But I'm not going to make you show the stoichiometry. So we're going to take negative 57,631 degrees, and we're going to divide it by 360 degrees. And that should give us what? But what are the units? That should give us rotations, yes? Yes, yeah, because one rotation is 360. Now, if it's negative, make sure you include the negative symbol. Otherwise, you're going to get messed up, okay? And I don't want you to get messed up. So let's do it together. Flush, and then we get negative 57631 divided by 360. I'm going to write that number down, negative 160.086111, so on and so forth. Now, I'm not going to make you show this work because I want you to be able to do this on your own. But what that means is we are rotating clockwise 160 full revolutions or rotations, whatever you want to call it. That just gets us back to the x-axis again. I am interested in the decimal part. That is a fraction of a single rotation. And I want to know what that is so I can figure out where it lands. Now, because the decimals keep going, we're not just going to type in 0.0861 because that doesn't preserve the decimals that the calculator is storing. So instead, whatever this whole number is here, we're going to add the opposite of it. So if it's a negative 160, we're going to now add 160 to it. Okay? And now the calculator throws more ones in there. This then gives us still rotations. Let me write this down on my iPad. Okay, so again, you don't have to write down what I'm writing here. This gives you 0.08611 of a rotation. Now we're going to take that number and do what? Multiply it by 360. So the same number that we divided by, that's rotations. If I multiply it by 360 degrees, that'll tell me how many degrees that is. All right, so let's see what that gives us. So we can just say times, and that'll recall the answer, 360. And we get negative 31 degrees. Is that enough to determine what quadrant it lives in? Yeah, as long as you get a magnitude, that is a scalar quantity, between 0 and 360, you should know where it lives, right? The negative or positive just means how much you're rotating to get there. Okay, so let's go ahead and draw that now. We'll draw negative 31. So here's my x and y axis. I'm starting, again, always on the positive x-axis. You don't even have to draw that. Negative means I'm rotating this direction, and then I'll stop right there, and then I'll call this omega. Now, I didn't draw 160 loops, did I? If you want to do that, you'll get vertigo. Your eyes will start spinning. I'm not really interested in you drawing all of those circles. Just know that it did go around 160 full times in the clockwise direction, and then another 31 degrees. So this is really all I'm interested. Can you get it into the right quadrant? And of course, then we could say that this angle terminates in quadrant what? What quadrant is this? 4. The terminal ray lands in quadrant 4. So this angle terminates in quadrant 4. And we're going to call that omega. Now, question. Is negative 50,631 degrees the same as negative 31 degrees? No, they're not the same angle at all. I mean, if you think about it, like 0 degrees then would be landing at the same spot as 360, which would be landing at the same spot as 720. But in terms of like skateboard tricks, 720 is a much more impressive trick than a 0, right? Hey, dude, watch, I practiced all night. Here's a 0. There you go. How was that, right? So they're not the same angle. It's not the same trick. But they land at the same place. So are they kind of related? They have something in common, don't they? What do they have in common? What? They landed at the same spot. So every angle in standard position is going to share an initial ray because they all start on the positive x-axis. But not all angles share this one. This is called the what? Terminal ray. Like a bus terminal, that's where the bus ends and starts, by the way. Yeah. or depot, right? We call that the terminal ray. So those two angles that are not the same have something in common. They share a terminal ray. That's interesting. Okay? All right. Everyone good on that? So here's what you would do then in the future. I know I said in the warm-up, don't ever go to the calculator if you don't have anything written down. This would be one of those exceptions because I want you to be able to do this fluidly and quickly, all right? So here's what I would just do next time on my own, right? Not writing anything down. All right, so negative 57, 631. I'm going to divide that by 360. Okay, boom. That gives me rotations. I'm going to add back that number to get the negative, boom, and then I'm going to remultiply by the same number that I divided by, and I get negative 31. Okay? So it's just a real quick way to get rid of the full rotations without having to add back 360 160 times. Got it? So divide, in this case, add, but sometimes you're subtracting. If that were a positive angle, you would subtract. So divide by 360, add or subtract the whole number, and then remultiply by 360. And you get an angle that is not the same, but has what in common with the original angle? Terminal ray. Very good. Terminal ray. All right. Cool beans. Did we already talk about y'all's reply? If I ever say cool beans, what y'all need to reply back? Did we talk about that? I forgot what it was, and we haven't been doing that. I don't know if I've said cool beans. What do we say? Hot cool beans? Do we say like hot chili? That's right. Hot chili. Okay. Cool beans. Hot chili. All right. Because unicorns love chili. Do the rattlers love chili? Reagan rattlers, do they also love chili? They probably do. Yeah. Not as much as the unicorns, right? Because they don't have hats that say that. Rattlers love chili. Okay. It's just, it's bursting out of our heart and we need to exclaim it. I mean, it's just one of those things. Unicorns love math. Unicorns love blue. Unicorns love other unicorns, and unicorns love chili. I mean, everyone knows that, right? Everyone knows that. All right. So how are we doing? Have we made progress yet today? Have we advanced ourselves through the notes? No, not really. Not really. But are we tying up loose ends? Yes, 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 yes. Yes, we sure are. Okay. Definition. Did y'all get to this? Okay. Here's an important definition. Just like the two angles that we saw, negative 57, whatever it was, negative 57, 631, and negative 31, they weren't the same angle, but they shared a terminal ray. We have names for such angles, okay? And the names of those angles in relation to each other is coterminal. Two angles that share a terminal ray are coterminal with each other. Now, in math, not always do the names make sense, right? But in this case, it's a perfect name. I can't think of a better name for two angles that share a terminal ray to be called anything other than coterminal. Because co means what? With, right? Or sharing, right? Cooperate. Let's operate together, right? You cut them open, I'll grab the spleen, right? Cooperate. Sharing is caring. Together. So together, and then terminal, of course, implies the ray that they share. Coterminal. All right? So here's what's cool. They are only how far apart from each other? Multiples of what? Full 360s, right? Full rotations. One rotation, or revolution as we'll call it sometimes, is 360 degrees. So these coterminal angles are full multiples of rotations away from each other in either direction. So here's the little formula that we can write down to devise any coterminal angle. Let's say you have a starting angle theta, all right? Then the coterminal angle, which I'll call theta, this is subscript COT for coterminal. That means that they're related. It's going to be your original angle plus 360 times n, where n is an element of what? What number group is that with the z's? German verb to count, right? We talked about at the beginning of the year. We went over number groups. It has to be full rotations, right? So could n equal 1.5? That would be 1.5 rotations away. That doesn't work, does it? It has to be full rotation. So like 0, 1, 2, 3, 4, right? But it could also be negative. -1, -2, -3, right? That's why this is plus 360n and not plus or minus. If you want to put plus or minus there, you can. But z is the, does it ring a bell now? Integer. Integers. The integers. The integers. Or the zintegers, if you want to call them that. All right, so whole numbers, 0, 1, 2, 3, 4, 5. That would be like 0 rotations away, 1 rotation away, 3 rotations away, 4 rotations away. Or negative whole numbers, -1 rotations away. That's in the clockwise direction. -5 away in the clockwise direction. Now, according to this definition, can an angle theta be coterminal with itself? According to this definition, can an angle be coterminal with itself? Sure. All right. In that case, what's the value of n? 0, right? 0 is an integer. So when n is 0, theta coterminal equals theta. Can you share with yourself? Sure you can. I'm hungry. I brought a full sandwich. Oh, but I'm hungry too. Okay, let's split it. I'll have this half, and then I'll have the other half. We're sharing together. But it's all still me, right? It's all still me. You could share with yourself. So yes, an angle can be coterminal with itself by definition. All right. Cool, cool, cool. All right. Are you ready to try example 4? Heck yeah. If theta equals 465 degrees, we want to find all the angles theta subscript coterminal. Okay, all the ones that land at the same place that fall in this interval. Okay, so that's a compound inequality. That means our coterminal angles have to be between -1,000 degrees and +1,000 degrees. The other way to write this in interval notation, I know y'all are interested in both notations, would be this. It means the exact same thing. Make sure you're always writing the degrubble when you're talking about degrees. So is 465 itself going to be in our list? Yes, bless you. Because 465 falls between -1,000 and 1,000. And it can be coterminal with itself. So here's what I'm going to do. I'm going to list these left to right. Let's go ahead and start with the list. 465. Just write it in the middle of your page and put a comma. We're going to list them from left to right. How do we then go ahead and find the other angles that are coterminal with it? Add or subtract 360 degrees. So I'll do it with my calculator here. You can grab one if you have one. So I'm going to type in 465, and I'm going to say plus, when n equals 1, that's 360. Is that between 0 and 1,000? Yes. So I'll write it down. That's 825 degrees. Now, here's what's cool. You can generate these recursively if you want. So the next one that's coterminal would be another rotation away, so you can add another 360 to it. And you get 1185. That's coterminal with 465. But does it fall within our interval? No, so it's out. Now, if you want, you could just type it in again, 465 plus 2 times 360. That would be 2 rotations away. Okay, so there's a couple ways to do it. I think it's easier if you're just trying to generate them one after the next. Just keep adding 360 to the previous. And I don't know if it said it on the video the other day, but your calculator is a learning creature. So if you say plus 360 once and hit enter, and then you say plus 360, oops, you got to say plus, it'll automatically call the answer, plus 360. Once you do it twice on your calculator, it knows what you're trying to do. So after that, if you just keep hitting enter, what is it doing? It's doing the same problem. Okay? Your previous answer plus 360, if you do it twice, 2 times, your calculator remembers, and all you have to do is keep hitting enter, enter, enter. All right? We call this recursive generation. We're generating these numbers recursively, one after the other. And the previous one, or the next one, requires the previous one. So these are all coterminal with 465, no doubt, yes? All coterminal. They all share the terminal array, but they don't fall within our interval. So are we done? Did we list them all? No, now we need to go backwards, okay? So you can either start with 465 now and subtract 360, or look what I'm going to do. I'm going to take my answer and subtract 360 once, and I'm going to take my answer and subtract 360 again from that, and now I've done it twice. My calculator remembers. I think this is kind of fun. I don't want, I'm playing around. So notice I'm now subtracting out full rotations. I'm rotating clockwise, and notice my numbers are getting smaller. Hey, there's my original one. So 465 minus 360 is 105. Do I want to write that one down? Yeah, that's between negative 1,000 and 1,000. Minus 360, or just hit enter. Negative 255, that one's in, right? I'll write it down. Hit enter. Negative 615, is that in? Yep. Oh, so much fun I'm having. Negative 975, did he make it? Yeah, and I'll do it one more time. Negative 1335, how's that? No, that doesn't work. Yeah, I mean, it is coterminal, right? Don't tell him he's not coterminal. He'd be like, yes, I am too, Mom, right? But he's not, he doesn't live in the interval that we're specifying, right? Yeah. So how do we write down our final answers? Well, notice I listed them all from least to greatest, but now because that is a solution set, it's a roster, if you will, right? Remember we talked about roster notation? You can say theta, ooh, I wrote a Q, oops, theta coterminal, and then you can put equals, if you put it as a set. It's not an interval, it's a set. So remember I said on the test, when we were finding the range and it was all real numbers, you say it's the set of all y's such that y is an element of the real numbers. When do we use an epsilon versus when do we use an equal sign? The coterminals that fall within our interval are equal to this set of numbers, okay? So that's an equal sign. But when you say the range is all y such that y is not equal to the real numbers, y is a single element that belongs to that set, okay? Anyway, there you go. Pretty easy, right? Pretty easy. All right, let's do this one on your own. If I start you with theta equals, let's see, what was the final score yesterday? 31 to 31 to 20. Okay, let's do a 31 20 degrees. Okay, I want you to find a theta coterminal that is 148 clockwise rotations away from this one. Go. Find a coterminal angle to this one that is 148 clockwise rotations away. Now this one you might want to write on your paper first. I might ask you for this. Write down the formula that you're typing into your calculator. Is anyone typing in 3120 and then just going plus or minus 360, plus or minus 360, 148 times? What if you're like at 130 and you're almost there and then you lose count? You're like, oh crap, was that 131 or 128 or dang, I got to do it all over again. So we don't want to do it that way. That might be fun. We don't want to do it that way. Are we adding or subtracting 360 multiples here? We're subtracting. How do we know we're subtracting here? Clockwise. Very good. Clockwise is always negative, all right? So here's what I would expect to see. Theta coterminal is 3120 degrees minus 148 times 360 degrees. Okay? Or plus 148 times negative 360. I don't mind if you do that. But we're subtracting because it's clockwise. All right, so am I going to be picky about your de Grubble symbols being there? Absolutely, absolutely. Okay, so now if you type it in, it's already on your paper. Should be relatively easy. We're just going to say 3120 minus 148 times 360. And we end up with negative 50.160 degrees. Do you need a comma after the 50? No. Is it okay to have one? Sure, yeah. It's a stylistic thing, right? If you like to stylize your answer, you can still do that. That's one of those things that you learn in middle school or baby school so that you can learn places, right? Ones place, tens place, hundreds place. And for large numbers, seeing commas does help you chunk it up into threes. Is that a million or billion? So it's still nice to have, right? If you want it, but it's not needed. All right, so 3120 and negative 5160. Same angle, yes or no? Very different angles, right? Very different angles. But they are what? Coterminal. Now, I'm trying to start a symbol. There is no symbol for coterminal angles. There's none out there that I know of. So I'm going to try and start a new symbol, and we'll see again if it takes off. All right? So here's the symbol that I want y'all to start using for coterminal. And if you go to college, just be careful if you use it and your professor doesn't count it right. You might want to explain to him, and he'll catch on and say, oh, that's good. So 3120 and negative 50.160. If I put equals, that would be incorrect. Yes? They're not equal. So here's what I'm going to do. I'm not going to put a not equal sign through it. I'm not going to do a slash like that because they are related. I'm going to put a circle around it like that. And now it resembles what? That resembles theta, which we use primarily for angles. But it's a double line theta, and so there's an equal sign through it. So they're not equal. They are what? Coterminal. Yeah. So this is the coterminal symbol that I want y'all to start using. Feel free to use it. I'm not going to count off if you use it. Mrs. Lincoln won't count off if you use it. Might your parents count off if you use it? Or your college professor or your eventual spouse? Sure. If it hasn't caught on by then yes. But in here, use it freely. Okay. So we got a de Grubble and a coterminal symbol. Excellent. All right. Here's a fun one. And this is kind of getting into the thick of what we're going to be doing with our twos clues problems that are coming up. For each angle, what the heck is that? Well, that's just a random variable that apparently represents an angle. So instead of theta, we can sometimes use this. Does anyone know what that one is? That's phi or phi. I don't know how you say it. Phi, phi, faux fum, right? Phi, phi, faux fum. I smell pre-calculus. Yum, yum. It's just another symbol. So for every angle phi, find the angle theta that is coterminal with phi. So instead of using subscripts now, like phi subscript COT, we're just going to rename the coterminal angle theta such that that angle falls, and this is going to be something you get used to. it's going to fall between 0 and 360. Now notice it's a compound inequality, but the left one is less than or equal to. So that means including 0 but not including 360. This is basically our comfort zone. This is within one positive rotation. This is our comfort zone. Because we have a very intuitive understanding. This is 0 degrees. This is 90 degrees. This is 180 degrees. And what's 3/4 of the way around? 270. Yeah. That should be almost intuitive. If not, write it down. If we could figure out what the positive measure of an angle is between 0 and 360, we'll know which quadrant it lives in, right? So let's do that. Negative 28.549. Remember, this is the one exception where I'm not going to require you to write down your work, right? We're just, because if you do, people usually lose points because they just piggyback on the previous result without rewriting it, and I don't want you to lose points. If you want to write it down off to the side on your bench, that's fine, but let's go through it together, all right? That's a huge negative angle. I want to know where it lives between positive 0 or 0 and positive 360. So first thing I do is I type in the angle. Do I need to worry about the negative? Oh yeah, don't let it trip you up. So just type in that negative angle. I'm going to divide it by what? 360, because that's the number of degrees in one full rotation. That converts it to rotations. Do I care about the first 79 rotations in the clockwise direction? No, because that puts me right back on the positive x-axis. So because that's a negative 79, I'm going to say plus 80. I'm sorry, that's one way to do it. Let me not teach you that way. Let's just type in plus 79. Let's just get rid of the whole number part, and notice the decimal part's preserved. See that? So get rid of the whole number, and then we're going to remultiply by what? 360. Okay, because that's rotations, and you get negative 109. Negative 109. So if you want then, on your paper, you could put negative 28.549 is coterminal with 109. Is that our answer, 109? Someone stop me. No. This is why the negative is important. It's coterminal with negative 109. Oh. How then can we get the answer that's coterminal with that one that's between 0 and 360? Yeah, at this point, if you end up with a negative angle that's between 0 and 360, just add one more full rotation to it. So just say plus 360, right? Just go around one more time, plus 360. If we had started with a positive angle, that would be our answer. That would be our answer. So theta is 251 degrees. All right, 251 degrees. Now, I slipped when I was first showing you how to do it. Instead of adding back 79, I added back 80. If you would have done that, gone one more full rotation, and multiply that number by 360, you get 251. If you understand why that works, that's fine. If not, just do what we'll do every time. Divide by 360, add or subtract the whole number part, whatever the sign is, do the opposite. Then take that decimal part and remultiply by 360. If it starts as a positive angle, like if that had been positive 28.549, then positive 109 would have been our coterminal angle. But if it starts as a negative angle, there's one last step to do, and it's simply to add 360 to get one more rotation away, and now you get positive 251 in this case. The Grubbles, right? And now I'm going to call it theta, okay, because it said to call it theta. And is that between 0 and 360? Yes. And are we running out of time? Unfortunately, yes. Did we actually make progress today? We did. We got to example 5a. I'm proud of myself. Fewer distractions. I'm getting better, Jenna. And everybody. All right. Have a great rest of your carrot cake day. Y'all can go.